Hi everyone. So for me it's a Friday afternoon and it's been raining all day, so it's kind of a dreary, glum day, but it'll probably be Monday or Tuesday before you see this video, so I hope that you had a good weekend and that you're ready for the week. So before we get started, I want to remind you that the interim reports are coming out this week, so grades are due on Wednesday at 12 o'clock noon. So that means that I'm asking you to turn this assignment in by 11, so that gives me time to get everything in the grade book. So please catch up on missing assignments and get this lesson turned in on time. So here we go. Okay, so we're going to be looking at some more identities today. So these are called double angle identities, and the reason they're called that is you'll see that all of them at the top of the page, instead of just saying sine of x, you'll see it says sine of 2x. Or cosine of 2x, or tangent of 2x. So the 2 implies the double angle. Okay, so we're going to pick one of the identities based on whatever is given to us in the problem. So let me show you what I mean. So for number 1, we have the cosine of x equals 3/5, and the directions say to find the cosine of 2x. So that's double that angle. Okay, so if you notice there are 6 identities, 3 of them have that cosine of 2x equals something. So you want to pick the one that would be best suited to this problem. So because we were given cosine of x up here, you want to pick the one that has cosine of x in it. So you'll find that it is in the second column, the second one down. So it looks like this: cosine of 2x equals 2 cosine squared x minus 1. So now we will take the number 3/5 and plug that in for the cosine of x. So that means you would keep the 2 there. Instead of cosine of x, plug in 3/5. That will be squared, and you'll subtract 1. Now, I think I've warned you many times that when you go to AP Calc, the majority of the time you cannot use a calculator of any sort. So you would have to do this by hand next year. So as a reminder, you would need to square the 3/5 first, then multiply that number by 2, and then subtract 1. So if you do all that, you would get the number -7/25. So your final answer for number 1 would be -7/25. Okay, so for number 2, this time we were given that the sine of x is equal to 3/4, and the directions say find the cosine of 2x. So again, there are 3 different identities at the top that say cosine of 2x equals something. So you want to choose the one that would match the problem we have. So we were given sine of x equals a number, so you want to pick the one that matches that, one that has sine in it. So if you look at the first column, the second one, you'll see that it looks like this: cosine of 2x equals 1 minus 2 sine squared x. So now we're going to take the number 3/4 and plug that in for x. So that will be 1 minus 2 times 3/4 squared. Okay, so to do this by hand, you would square the fraction first, then multiply by 2, and then whatever you get for that, you would do 1 minus that number. And you would need to get a common denominator since it's subtraction. So after doing all of that, you would get -1/8. I'm kind of skipping over that part because I really have no way to monitor whether you're using a calculator or not. I'm just kind of warning you that next year, by hand, you will have to do it. So if you're really serious about taking AP Calculus, you probably should be practicing that now. Okay, so for number 3, we have the cosine of x equals 5/13, and also that the sine of x equals 12/13. Now notice that this time we are asked to give the sine of 2x. Of the 6 identities at the top of the page, there's only one that has sine of 2x equals something. So it's the first one in the first column. It's sine of 2x equals 2 sine of x cosine of x. So we're going to plug these two numbers in. So the number 2 would be there. The sine of x is 12/13. And the cosine of x is 5/13. So this is just multiplication of fractions. So you would multiply straight across if you were trying to do it without a calculator. So straight across, if you were to do that one, you would get 120 over 169 is equal to the sine of 2x. Oh, goodness. I wasn't holding that very well. Sorry, guys. There you go. Wasn't paying attention to the screen. Okay, so final answer for number 3. Okay, so number 4, it says that the tangent of x equals 3/2. And we are finding the tangent of 2x. So there are two identities at the top for tangent of 2x, but I'm going to pick the one that contains tangent of x because that is what I was given in the problem. So look at the first column, the third one. You should see this one. Tangent of 2x equals 2 tangent of x over 1 minus tangent squared x. Then we are going to plug in the number 3/2. So at the top you would have 2 times 3/2, and on the bottom you would have 1 minus 3/2 squared. Now whether you use a calculator or not, you still need to be careful. What you should do is multiply the numerator separate from the denominator and then do the division. So for instance, if you were to multiply 2 times 3/2, just that much, you would find the answer to be 3. So you'd put that in the numerator. And then in the denominator, if you were to do this part, you would square the fraction first, then do 1 minus that fraction with a common denominator, and it works out to be -5/4. So you have a fraction 3 divided by -5/4. Okay, so when you divide with fractions, you multiply by the reciprocal. So think of it as 3, like 3 over 1, multiplied by the reciprocal of this one. So it would be -4/5. And then you would multiply straight across and get -12/5. So your final answer for number 4 is -12/5. Okay, so number 5, we have the cosine of x is 15/17. But it also gives us some other information. It's saying that x, the angle, is somewhere between 3 pi over 2 and 2 pi. And it says to draw a reference triangle. So think of the reference triangle being on the XY coordinate plane. 3 pi over 2 is at the bottom, and 2 pi is on the right. So that means our triangle, or our angle I should say, is in quadrant 4. So draw any angle in quadrant 4, that will be angle x. Make a perpendicular to the x-axis. And then we're going to fill in what we know using Sohcahtoa. So cosine in Sohcahtoa is adjacent over hypotenuse. So compared to x, 15 would go here, that's the adjacent, and the hypotenuse would be 17. So we are missing this piece over here that we will need for this problem. So we would need to do the Pythagorean Theorem to get that missing piece. So you've done this many times. Let's do it now. So it'd be 15 squared plus y squared equals 17 squared. So 15 squared would be 225. 17 squared would be 289. You would subtract the 225. So 289 minus 225 is 64. you would take the square root of both sides, and remember it's always plus or minus, and then 8. Okay, then you would look at your drawing. In quadrant 4, we're trying to find this piece that is going down from the x-axis, so going down implies that that would have to be -8. Okay, so now we have all the values that we need in our triangle. So I'm going to erase this because I need more space, but this was just the Pythagorean theorem right here. Okay, so this problem asks you to do 3 different things, so we just have to go one by one. So one of them says find the sine of 2x. There's only one option of your identities for sine of 2x, so that one is 2 sine x cosine x. So the number 2. And then for the sine of x, you would look at the triangle and remember Sohcahtoa. So sine is the opposite over the hypotenuse. So from the x, -8 is opposite and 17 is the hypotenuse. So for sine, you would put -8 17ths. Now the cosine we were given originally to be 15 17ths, so you don't have to calculate that. Okay. So then you would multiply these, so fractions are just multiplied straight across. So you would find that answer to be -240 over 289. So that one would be the sine of 2x. Now you are asked for the cosine of 2x. So again, I'm going to erase this to have more space. So get this down, stop the video, and catch up if you need to. So cosine of 2x, you have 3 options. There are 3 different things on the paper that would match that. Now, since I was originally given cosine, I'm going to use the one that involves cosine. So that was the one we used earlier. Cosine of 2x equals 2 cosine squared x minus 1. And I'm going to fill in the number 15 17ths. So it'd be 2 times 15 17ths squared minus 1. So without a calculator, you would do the fraction squared first, multiply that answer by 2, and then subtract 1 from that. So if you were to do that, you would get 161 out of 289. So that's the cosine of 2x. And again, I'm going to be erasing this in a minute, so pause and catch up if you need to. Okay, so notice that the next part is the tangent of 2x. Now there are 2 options for tangent of 2x. You can really use either one, but look at the one on the second column, the third one down. We haven't used that one yet, and this would be a good time to do it. So we would have the sine of 2x over the cosine of 2x equals the tangent of 2x. That's the one I'm going to use now. Now the reason why I chose that one is because we have already calculated what this and this are, so we can just plug in the numbers that we've already found. Like we found earlier that the sine of 2x was, what was it again? -240 over 289. And then we found the cosine of 2x just a minute ago. That was the 161 out of 289. And then we can divide those 2 fractions. So remember, division of fractions is multiplication by the reciprocal. So you would keep the first one the same and multiply by the reciprocal of the bottom one. So that would be 289 over 161. And this is really simple because the 289s would cancel out and you would just multiply straight across. So you would have -240 over 161. You didn't even need a calculator to do that. Okay. So that one is the tangent of 2x is equal to that. Okay, so we have one more to do. Almost done. And this is another one where you will need to draw a reference triangle in one of the quadrants. So let's see what we have this time. Okay, so for number 6, it is the sine of x equals -3/5. And it says in the problem that x is in between pi and 3 pi over 2. So pi is here on the left and 3 pi over 2 is down here at the bottom. So that must mean the angle is somewhere in quadrant 3. So just pick any angle in quadrant 3, label that x, drop a perpendicular to the x-axis, use Sohcahtoa to fill in the values. So Sohcahtoa means that sine is the opposite over the hypotenuse. So across from the x over here would be the -3, and the hypotenuse would be 5. So then we would need to do the Pythagorean Theorem to get this piece up here. So we would have to do x squared plus -3 squared equals 5 squared. So of course -3 squared is 9 and 5 squared is 25. We would subtract the 9 over, so x squared would be 16, square root both sides, and x will be plus or minus 4. Now you have to look at our drawing. We're in quadrant 3, and the piece we're looking for is going to the left of the x-axis. So going to the left implies that that number must be a negative, so it must be -4. So I'm going to erase this in just a sec, so pause if you need to. Okay, so it asks for all 3 things again, so we're going to find the sine of 2x. There's only one identity that it could be. It's the 2 sine x cosine x one. Okay, so the number 2, the sine of x we were given in the problem to be -3/5. And the cosine of x, we'll need to look at the triangle for. So cosine is adjacent over hypotenuse. So adjacent would be the -4, and the 5 would be the hypotenuse. That would be -4/5. So with fractions, you just multiply straight across. So if you do that, you will get 24 over 25. So that will be the sine of 2x. Okay, so next we have to give the cosine of 2x. And you have several options, but the best choice would be to pick the one that involves sine x, because that's what we were given in the problem. So I'm going to do that. I'm going to choose the one that looks like this. Cosine of 2x equals 1 minus 2 sine squared x. And then I'm going to fill in -3/5 for the sine. So it will be 1 minus 2 times -3/5 squared. So without a calculator, you would be squaring the fraction first, multiplying that answer by 2, and then subtracting 1 minus that number by getting a common denominator. So to save time, I'll tell you that that works out to be 7/25. So that will be the cosine of 2x. So on the last part, we have to get the tangent of 2x. And even though there are 2 options on the sheet for the identities, I'm going to choose the one in the second column, which says that it's the sine of 2x over the cosine of 2x. I'm picking that one because we already know these 2 values from the previous 2 steps that we made. So we just found that the sine of 2x was 24/25. And then the cosine of 2x, it was 7/25. So you would be dividing those 2 fractions, which means multiply by the reciprocal. So it would be 24/25 times 25/7 if you flip it. The 25s would cancel out, and you'd be left with 24/7. And that's it for the tangent of 2x is done. All right, y'all, so that's it for today. Again, be sure you get this in on time because interims are on Wednesday. Take care. Miss you guys. Bye-bye.